Okay, this video goes with lesson 2.5, Angle Relationships, which is from Key Curriculum Press. It's with our section 2.1 on parallel lines and special angles. So let's see what we have here. Without using a protractor, we want to find these angle measures. So if we look at what we have going on, we have vertical angles and linear pairs. And these three angles would be 180 and so on. So let's see what we have. So this is going to be 112 degrees. Now these two angles are marked as congruent, so that's going to be 112 degrees. Because of vertical angles, B is going to be 112 degrees. And C and 112 are a linear pair, and A and 112 are a linear pair. So these two angles are going to be congruent. We can also see by vertical angles, but 180 take away 112 comes out to be 68 degrees. So A is going to be 68, and C is going to be 68. Okay, let's look at number 2. These three angles together need to make 180 degrees. The angles that are given to us add up to be 53 degrees, and 180 take away 53 is going to be 127. So angle A must be 127. Looking at number 3, by vertical angles, B is a 40. D is going to be a 70 by vertical angles. See what else we got. This is really the same thing as angle, whatever this angle is by vertical angles is this angle here. And by vertical angles, this is the same as this angle here. So if we look here at, let's call these angles, we don't know X. So what I'm thinking of is these angles here have to add up to 180. So the two numbered angles give us 110. 180 take away 110 is 70. And these two angles are congruent, so if we do 70 divided by 2, we get 35. So each one of these angles must be 35. And since these are vertical angles, those are also going to be 35. So we found all those angle measures. Looking at number 4, 66 and A need to be a right angle. So 90 take away 66 comes to be 24. And altogether, these angles need to make 180. We have a 42 and a 66, that's 108. Plus another 24 gives us 132. So it's going to take another 48 degrees to get to 170. So B must be 48. Let's move up. Now we have an exterior angle theorem from the past that says that this angle is equal to the sum of the remote interior angles. This is a 90. By vertical angles, B is going to be a 90. And A is going to be a 90 because of the linear pair thing. So we got those angles there. By vertical angles, E is going to be 132. And D is going to be a linear pair. So that's going to make 48 degrees to make 180. And then we could do either exterior angle equals the sum of the remote interiors. So 103 take away 90 gives 42. So C is going to be 42. Or also we could have done 90 plus 48 plus X equals 180 and found 42 that way. Let's look at A. This is 70. So to make the right angle, A must be a 20. B and C together make 90. We can't do anything with that yet. Let's look at this X that makes this 70. We got this line goes through here and through there. So D has to be 70 because it's a vertical angle. Together with E, these need to add up to 180. So 180 take away 70 gives us 110 for E. Now, if we look at the lines that make up E, let me use the markup tool here. We want to do angle E, which we found is 110. So here's one side of angle E, and here's the other side of angle E. So this, by vertical angles, C, B, and A need to add up to 110. So let's see. B is marked, B and A together are marked as being a 90. And together these all have to be 110. So that leaves angle C to be a 20. Oops. So C is going to be 20. And let's see. These angles together have to be a right angle. And these angles together need to make a right angle. So B must be actually 70 degrees. So 70 and 20 makes 90 for this angle. 70 and 20 makes 90 for this right angle. And we got everything that we need. Let's look at 7. Here we have a linear pair with 110. So A is going to be 70. Here we have a vertical angle. So 100 can jump down there. They're telling us this is a 25. Altogether, these three at the bottom need to make 180. We have 125. That's only 55 degrees to be that angle there. By vertical angles, go this way and this way, cross this way, and up this way. This angle B is vertical to 55, so that's going to be a 55 degree angle. And then altogether, these need to make 180, or if this is a 25, I can just, the easiest way by vertical angles, C also has to be 25. So we have those angles. Here we have a pair of adjacent congruent angles that make a linear pair. Each one of these must be a 90. Let's move on. The sum of the measures of two acute angles equals the measure of an obtuse angle. This could be sometimes true, but a counterexample might be, let's look at a 45 and a 45. That adds up to 90, which isn't obtuse. It's right on the edge of being obtuse. But I could think of a 30 and a 15. Those are two acute angles that are going to stay acute. If I wanted to come up with one that was obtuse, which would be greater than 90, I could think about it like maybe a 70 and a 60 degree angle. Those are both acute angles, but they're going to add up to 130, which makes it obtuse. So sometimes you can get a combination that comes up to bigger than 90 or obtuse. You can come up with one equal to a right angle. You can come up with a combination that comes up less than 90. Number 10, if XAY and PAQ are vertical angles. Now, for this one, I'd have to draw a diagram. So I'm going to draw XAY. And then as a vertical angle, we want to draw PAQ. PAQ. Okay, so I set these up as vertical angles with each other. Then let's see. So if these are vertical angles, XAY and PAQ, then either XA and P, or XA and Q are collinear. Now XA and Q turn out to be collinear on this one, so I'm going to say that's an always. The sum of the measures of two obtuse angles equals the measure of an obtuse angle. That's gonna be a never. An obtuse angle is bigger than 90. So let's say 91 degrees. You had two 91s, you're at 182, which isn't considered an obtuse angle. An obtuse angle goes between 90 and 180. So you can actually add those together and be outside the measure of what we would call an obtuse angle. Number 12, the difference between the measures of the supplement and the complement of an angle is 90. Let's look at this one. They make a complement. Let's just use this, okay? So this is a 90. This is a 90. So angle 1 is a supplementary angle to angle 2. So the difference between the measures of the supplement, which is 90, and the complement of an angle, well, a 90-degree angle actually has no complement. So that works for that, but it's not so good. Let's do a diagram more like this. So we're going to talk about this angle here. So the difference between the, and let's put a number in. Let's call this a 40, which makes this a 150, or 140 rather. So you have a 40 and a 140. So the difference between the measures of the supplement of an angle, so the supplement of this angle is 140, and the complement of the angle, now the complement of the angle is going to be 50, and the difference of those is going to be 90. So this seems to be a true statement. Uh, 13, if two angles form a linear pair, they're going to be supplementary, not complementary. That's going to be never. If a statement is true, then its converse sometimes is true. Now, if a statement is true and its converse is true, we can write it as a biconditional, which makes for a good definition. But you still have to evaluate them separate. Let's look at number 15. If one angle of a linear pair is obtuse, which means bigger than 90, less than 180, since you have to get to 180, the other one has to be an acute angle. If A is equal to B, and the supplement of B is 22, okay, so if angle B, let's draw this out. So I'm going to draw an angle B. So here's angle B. Well, here's angle B. And it says that the supplement of B is 22 degrees. So for this one, 180 take away 22 is 158. So the measure of B is 158. So if A is congruent to B, and the supplement of B is 22, then A must be the same thing as B. So A is going to be 158. 17, if P is a right angle, and P and Q form a linear pair, then the measure of angle Q is going to be 90. So you got this idea here where P is a right angle, and P and Q both form a linear pair, then the measure of angle Q must be 90. 18, if S and T are complementary, and T and U are supplementary, then U is what kind of an angle? So if S and T add up to 90, and T and U add up to 180, not so sure about this one. And 19, switching the if and the then parts of a statement changes the statement to its switching those two parts changes an angle to its converse.